A very warm welcome from my side, from the Austrian Ministry for Climate Action. It's my pleasure to introduce the EGRD webinar on critical minerals in clean energy technologies, looking at the diverse agenda and the interesting contributions that are planned. Minerals are essential components in many of today's rapidly growing clean energy technologies, from wind turbines and electricity networks to electric vehicles. Lithium, nickel, cobalt, manganese, and graphite are crucial to battery performance, longevity, and energy density. Rare earth elements are essential for permanent magnets that are vital for wind turbines and EV motors. To successfully deliver the ambition of the Austrian government of climate neutrality by 2040 and a target of 100% renewable electricity supply by 2030, the requirements for these minerals will hugely increase, meaning that the energy sector is emerging as a major force in mineral markets. However, their rising importance in a decarbonizing energy system requires energy policymakers to consider potential new vulnerabilities, such as price volatility and security of supply. Encouraging circular uses, including advanced recycling capacity, strengthening efforts for sustainable sourcing, and promoting technology innovation for material substitution could help diversify and secure the supply of critical minerals. Therefore, I'm happy to support the IEA's initiative on critical minerals and their role in energy transitions, which will be the focus of today's webinar. I would like to thank the EGRD for the close cooperation and the opportunity to organize this webinar together. Austria is an active participant in the IEA's technology collaboration programs, disseminating the results to the national R&D community with events like this one. Within the RDI initiative Circular Economy, the Federal Ministry for Climate Action also launched a national program to foster research and development in the area of circular economy, allocating a budget of 26 million euro for the first 2 calls. Finally, it's my pleasure to see this webinar being connected to the Mission Innovation Austria Week, providing a platform for all who work on the development and implementation of solutions transforming today's energy system. The main conference days are taking place next week in Linz, in Vienna, and Stegersbach. I'm looking forward that this webinar will contribute to the outcome of the Mission Innovation Austria Week and wish you all interesting debates.
So many thanks for the welcome address by the Austrian Minister Leonore Gewessler. My name is Birte Holst Jørgensen. I'm a senior researcher at the Technical University of Denmark, the Department of Wind and Energy Systems, and I'm chair of the IEA Expert Group of R&D Priority-setting and Evaluation, EGRD. Please notice that this webinar will be recorded. A few words about EGRD. It's an informal expert group that for more than 25 years have advised the IEA Committee on Energy Research and Technology, CERT, on topics important to accelerate the energy transition. This urgent need is our mission. It is our why. In practice, what we do and what we also do today is that we examine analytical approaches to energy technologies, policies, and R&D. And we also promote dialogue and information exchange on methodologies and approaches related to technology assessment, priority setting, and evaluation. And how do we do it? We organize semi-annual expert workshops, or during the pandemic, we shifted to webinars. But irrespective of format, we invite practitioners and researchers to exchange and discuss R&D topics of relevance to the energy transition. Just in 2021, we organized 4 webinars, one on hydrogen, hosted by the Institute of Applied Energy in Japan in November, a second one on impact assessment of energy innovation policies, hosted by the IEA in September. Circularity in the clean energy transition was hosted by Nordic Energy Research in April. and the role of behavioral aspect in reaching net zero emission by 2050 was hosted by Switzerland. We make workshop summaries, and they are publicly available and posted on the TCP end users webpage. I will put that link in the chat afterwards. Today we focus on critical minerals. Critical minerals are indeed critical to the transformation of our energy system. And just to give you an example from my own backyard, next week in the Danish city of Esbjerg, the prime ministers and ministers for climate and energy of Denmark, Germany, Belgium, and the Netherlands, and also the president of the European Commission and the European Commissioner for Energy, and different directors of energy companies will discuss how to raise the ambition with regard to the extraction of wind energy in the North Sea and set out a joint vision for the North Sea powerhouse. This is very good for the climate. It's definitely also good for being independent of Russian fossil energy, but it's perhaps less so regarding the dependency of critical mineral supplies. Wind and other renewables will namely require an enormous amount of critical minerals to be used in permanent magnets, batteries, electrolyzers, power grids, and many other places. And this demand will accelerate exponentially in the years to come. This webinar will dive deeply into the availability and reliability of these minerals. We will explore what sort of research is needed to unlock new supplies, promote more efficient use of them, enable substitution, scale up recycling, and improve the production, operation, and processes in a sustainable way. We will also look into the use of artificial intelligence and machine learning and how these may help us accelerate the knowledge creation. And we will discuss how governments can support this important research area, not least facilitate international research collaboration so that we can use our common knowledge resources in the best possible way. After all, knowledge does not recognize borders. We have 3 sessions. They will each be moderated. You are welcome to post your questions after each presentation, and the moderator will make sure that this is done in a proper way. I will now hand over the screen to Johannes Tambornino. He is Vice Chair of EGRD. So, Johannes, the screen is yours. Thank you very much.
Thank you very much, Birte, for the nice introduction, and warm welcome to the audience, to everybody also from my side. This session number 1 is a quick session, so we have roughly half an hour, and we want to get a good overview on why do we have to secure and diversify investments in critical minerals. And this session will have only one presentation, but a very important one, because we will have a presentation on the recent IEA special report on the role of critical minerals in clean energy transition. And this presentation will be given by Tae-Yoon, and he is a senior energy analyst at the IEA, working in the Energy Supply and Investment Outlook division. And he is a main contributor to the IEA's flagship publication, The World Energy Outlook. And he was also one of the leading authors of the mentioned publication. Thank you, Tae-Yoon. The floor is yours.
Thank you, Johannes. It's a pleasure to be here. I will share my screen to put up the slide. Hope you can see the slide correctly. So it's a pleasure to be here. Today I will go through some of the key findings of the report mentioned, our special report on critical minerals we released last year, with some inclusion of the recent market development. Despite the pandemic in 2020 and 2021, we have seen some growing momentum for clean energy transitions, as many countries and companies announced plans to reduce their emissions to net zero by sometime mid-century. But one issue about that is the this clean energy system is built on minerals and metals. So as we advance energy transition, in a way, we are shifting from a fuel-intensive energy system to a mineral-intensive energy system. For example, a typical electric car requires 6 times more mineral resources than a conventional car. Likewise, offshore wind requires 13 times more mineral resources than a similar-sized gas-fired plant. So this underlines the need for policymakers to broaden their horizon to incorporate this new aspect in the energy security discussions. So first question we had to answer when we are tackling this topic is about how much do we need, or how much could demand rise? Here, the short answer is achieving global climate goals requires 4 times more mineral resources than today by 2040. An even faster energy transition to hit global net zero emissions globally by 2050 means 6 times more mineral resources than today by 2040. And this growth is mainly led by electric vehicles and battery storage, but also there are some fair contributions from the grid networks, transmission and distribution lines, and also the low carbon power generation such as solar and wind. But here on the left side, we are seeing 4 to 6 times demand growth, but some minerals and metals, such as battery metals, shows much larger the scale of demand growth. For example, the lithium demand in clean energy sector grows by 40 times in our climate-driven scenario over the next 2 decades. And likewise, the nickel, the graphite, cobalt all see some 20 to 25 times demand growth over the next 2 decades. So this huge expected growth has some 2 major implications on the energy system and also the pace of energy transitions. First, there are some strengthening linkages between the energy sector and also minerals and metal markets. In the past, in 2010, just some 10 years ago, the share of clean energy technologies in total mineral demand was minimal. But already in 2020, the lithium demand in EVs and energy storage has become the largest consuming segment of lithium demand already today. And this trend is set to accelerate in our climate-driven scenario, where the clean energy sector taking over 90% of total lithium demand. And also this trend are visible for other minerals and metals, including cobalt, nickel, and copper and rare earth elements. This means increasingly the energy sector stakeholders need to understand what is happening in the minerals and metal market. And likewise, the industry stakeholders in the mineral metal industry need to understand what is happening in the energy sector, in the clean energy space. So there are some strengthening linkages between these 2 industries going forward. The second implication is about the cost of clean energy technologies. So over the past decade, we have seen some rapid reduction in the cost of clean energy technologies from solar panels, wind turbines, batteries, due to the economies of scale and also technology innovations. But the outcome of that is now raw materials, including minerals and metals, account for a larger portion of total cost of clean energy technologies. That means any price spike or price fluctuations in the mineral and the metals can have a major impact on the cost of the cost of clean energy technologies. For example, the share of cathode materials in battery pack was less than 5% some 5-6 years ago until 2016, but the figure is already over 20% now. So that's the underlines the huge impact of raw materials in the total the cost of clean energy technologies, and also in turn the investment requirement for the energy transitions. We already have seen some rapid growth, rapid rise in commodity prices since 2021. So since 2021, we have seen some broad-based increase, the price increase for many the energy transition minerals, from the lithium to cobalt, nickel, the aluminum. So due to some growing pressure on supply chains and also rising demand and also concerns about tightening supplies, the price for lithium and cobalt more than doubled in 2021, and also those for copper and nickel, aluminum all rose by some 25 or 40%. And this trend has continued into these first few months of 2022. So lithium has especially seen some very astonishing 2.5 times demand price increase since the start of the year. And also the prices for nickel, aluminum have also sustained their upward march, due in part by the Russian invasion of Ukraine. So for most these minerals and metals that are vital to energy transitions, the scale of price increase was since 2021 was a lot higher than the largest annual increase observed in the 2010s by a wide margin. And this rising the raw material prices are already affecting the cost trend for many clean energy technologies, from batteries to solar panels to wind turbines. The trend of rapid cost reductions over the past decade has mostly reversed in 2021, with prices for wind turbines and solar PV modules up by some 9% and also 16% respectively. The prices for lithium-ion batteries remained relatively stable in 2021, but we are expecting a major uptick in 2022 as the impact of rising commodity prices are reflected in the product prices. This is not to say that further the cost reductions for clean energy technologies are not possible, but increasingly this effort faces an uphill neutral battle from the pressure from rising the raw material cost, which requires a redoubling of the effort to reduce cost to keep the overall cost on a downward trajectories via technology innovation and also the energy efficiency improvement and also economies of scale. Moving on to supply side, the key issue about supply side is about higher level of geographical concentration of productions. When we talk about the geopolitics in the energy system, we often talk about the OPEC and the Middle East oil and gas sector. But the level of concentration is much higher for many of these minerals, from copper to cobalt and lithium. So in many cases, top 3 producing countries control well over 3/4 of global production, and in some cases, a single country control well over half of the global productions. But it is not just about mining. When it comes to processing and refining, and the level of concentration is even more visible with China's strong presence across the board, as country had invested heavily in the mineral supply chain to support the growth of its clean tech manufacturing industries. So why is it matter? So why is the problem? So when this higher level of concentration means when there are some physical disruptions or trade restrictions or other event happens in a major producing country, and it can have a major impact on global supply and global prices. And we are seeing this impact from the recent geopolitical tension by Russia's invasion of Ukraine. And another issue on the supply side about whether the future supplies will be in a position to meet rising demand in climate-driven scenarios. And the result and outcome varies depending on the minerals you're talking about. But in general, today's supply and investment plans are geared toward some gradual action on climate change. So there are some looming mismatch between the mineral supply and also the strengthened climate ambitions. And these challenges are compounded by some long lead time to develop new projects and also the declining resource quality. And some more about the resource quality. When the concerns about resources mainly related to the qualities rather than quantities. There are some in terms of absolute amount, there are some abundant mineral resources in the world. But the question is the average, the ore quality is actually declining across the board. For example, in Chile, which is the largest producer of copper, the average grade for copper has declined by some 30% over the past 15 years. And this means declining resource quality means to extract the metals from the ore requires much more energy. And this means much higher cost and much more emissions and much more waste generated from to extract the same amount of metals, which is also the issue need to be tackled. Another question we had to answer when we are conducting this study about, because the many energy transition minerals have a higher emission intensity than bulk materials. So when you take into account the emissions from mineral development, then in practice, how clean are the clean energy technologies? So to answer these questions, we compare the choice today between buying an electric car and buying a gasoline car, looking at their total life cycle emissions. So here on the left side, you can see the life cycle emissions for gasoline car. And there are some emissions from the vehicle manufacturing phase, but the majority comes from the fuel that is combusted. On the electric vehicles, there are some emissions from vehicle manufacturing and also battery manufacturing, which is actually higher than that of a gasoline car because of the battery manufacturing and also the emissions from mineral development. But the gap is not that huge, even though we consider the higher emissions from mineral development. So the question about the life cycle emissions effectively boils down to the question about the carbon intensity of the grid to charge the electric vehicles. So when we consider some average global the electricity mix in our climate-driven scenario, the life cycle emissions of an electric car are around half of those of the gasoline car, with some potential for further reductions when using cleaner electricity. So this is not to say the tackling emissions or other environmental issues is not critical. It is very critical to tackle these emissions and also all other environmental issues associated with the mineral development. But at the same time, at least for emissions and the emissions from mineral development don't undermine the climate advantage of the clean energy technologies in our view. So in the report, we presented some 6 key areas of actions to ensure reliable and also sustainable supply of minerals. And first item is about ensuring the adequate investment in new diversified sources of supply. But that the most important thing for policymakers is to give some strong signals to the market that saying that energy transitions are going to happen. Otherwise, the companies will be hesitant to commit large-scale capital for new project development. And also, there's some scope to improve geological surveys and also streamline the permitting procedure and also to raise the awareness about the public acceptance about this important role that minerals and metals can play in the energy transitions. For example, in the earlier part of my presentation, I showed our baseline, the demand projections for minerals and metals, but also there are huge, significant level of uncertainties when projecting demand. And there are 2 main sources of the uncertainties. One is from the technology uncertainties, where how the specific technology will evolve over time. And the second one is the strength, the stringency of the climate policies. So we tried to capture understand the range of these uncertainties. We developed some 11 alternative technology cases to look at how different technology choice could bring the result in different energy, the mineral requirement. So here you can see a lot of dots or diamond in different colors, but basically the blue dots means our projections in the step scenario, which is the baseline scenario, which take into account the existing and announced policy intentions. And the orange and red, the diamond means our result in our sustainable development scenario, which is our low carbon scenario. And within that, and we have some various technology cases where, for example, in the batteries, we are seeing the high nickel chemistries is actually taking the market share. But what if this trend is slowed and other chemistries take a much higher market share than our base case? And for example, the solid state batteries, for example, we are expecting that comes online in earnest from around 2030s. But what if this is much faster, this is commercialized much faster than the base case expectations? And also in the grid networks, and how about the higher uptake of DC systems or the aluminum, the replace copper use in grid networks, much larger scale than our base case. So here the 11 alternative cases shows the range of demand under different technology pathways. But as you can see from the chart, the gap from technology uncertainties, also there are some quite substantial uncertainties, but also the largest gap comes from the stringency of climate policies. So whether the energy sector is following STEPS trajectories or SDS trajectories. So that is why it is important policymakers to give strong signals to the market energy transitions to close the gap and reduce uncertainties, and also to incentivize investment in the new supplies. And in 2020, we actually have in 2021, we saw some notable uptick in investment. So here we can see the capital expenditure for non-ferrous metals, excluding coal and iron ore. So until 2016-17, we have some slowdown in investment, and it has been picking up. But in 2020, there's some big dip due to COVID-19. But in 2021, we have seen some notable uptick in 2021, and also with some soaring commodity prices, we are expecting the the momentum might be maintained in 2022 as well, which is encouraging. But given the large scale of demand growth expected in our climate-driven scenario, still this trend needs to be sustained for longer term. And second, the item is about the promoting the technology innovation at all points along the value chain. So when I think that this is often the under ignored in the policy discussions, but this is very important because in the past, when there are some market strains, it is the technology innovation that play a major role in reducing those strains. So the scope of technology innovation can include both demand side and supply side. On the demand side, the technologies to reduce material intensity or enable the material substitution can play a role in reducing the demand for materials. But also on the supply side, the technologies to allow the metal extraction, metal recoveries from lower ore grade or waste streams could also unlock much more sizable volumes, supply volumes, and in turn contributing to reducing the gap between demand and supply. So both side and technology innovation can play a major role in reducing the possible market tightening. And third element is about scaling of recycling. So the system for recycling is relatively well established in some of the bulk materials such as steel and aluminum, but this is not yet the case for many of the energy transition minerals because of the market size was relatively small in the past. But we think this will have to change as we are expecting a surge in the amount of spent batteries, spent solar panels, and spent wind turbines from around 2030s. If not addressed, and the burgeoning amount of spent materials could pose a both burden to manage waste, but if well addressed, and this can be a valuable sources of minerals and metals that are critical to support the energy transitions and also reduce the burden for waste management. And fourth item is about enhancing supply chain resilience and market transparency in terms of the pricing mechanisms and also the contractual arrangement. And fifth element is about mainstreaming higher the environmental and social standard and governance standard. We think there are some strong linkages between the higher environmental and social governance standard and also the security of supply, because nowadays investors and consumers are calling for the volume that is sustainably and responsibly produced. But if you look at the supply picture, and the large part of today's supply is coming from the region with either lower governance score or higher emission intensity. That means if the ESG performance doesn't rise, then consumers need to compete for a small pool of supply that is responsibly and sustainably produced. That could create the layers of market strains going forward. So enhancing the ESG performance and also mainstreaming ESG consideration in the energy security discussion can also contribute a lot to enhancing the security of supply of minerals. And also the mainstreaming the ESG consideration can also incentivize investment in diversified sources of supply, because many of the potential entrants in advancing economies have a higher ESG standard than the incumbent players. So that also can contribute to enhancing the reliability of supply. Finally, we think that there's no single country can tackle these issues alone. So there's some naturally strong case for international collaboration between the producers and consumers, with some regular policy dialogue and also the harmonizing regulations about recycling and also discussion about the ways to incentivize investments, etc. So here, I can stop here. So thank you for your attention. I'll be happy to take any questions and comments you have. Thank you.
Thank you very much for this very detailed and comprehensive presentation. So I'm really curious to have an in-depth look at the publication and understand some of the sources and graphics better. There have been some questions by participants in the chat, and I will briefly go through them. So first of all, there was a question by Herbert Kreisberger, namely from your point of view, does the price increase in minerals counterbalance the learning curve for renewable technologies in coming years?
So I think that there are two factors in play. So in the past, the learning curve and technology innovation and efficiency improvement, economic scale outweighed the impact of the raw materials, partly because of the raw materials accounted for a small portion of the total cost of renewable technologies. But as other cost elements come down, So the now raw materials account for larger portion of total cost, as I showed in the slide. So that means now there are some battles between the rising the prices from raw materials and also the effort to reduce cost from other elements. So it is not to say the cost reductions is not possible, but we think there are some increasing uphill battle between these two opposing pressures. So that means some further strengthened effort to reduce the cost from other elements to offset the impact from underlying pressure from raw materials. That will be.
Okay, thank you very much. Then we have a second question by Carlos Alberto Fernandez concerning not the greenhouse gas emissions, but other factors. What about environmental impacts linked to mineral extractions other than greenhouse gas emissions? Did you analyze these also?
Yep. So we, in the report and in the environmental aspect, we look at these four broader aspect. One is the obviously emissions, the greenhouse gas emissions, but also there are impact on water use because some lithium mines and copper mines use a lot of water to extract minerals and metals, and also the waste is another issue. Waste and tailings is another big issue, and also biodiversity is another environmental issues. And so we they focus more on the emissions naturally, but also there are some other environmental impacts should not be ignored. For example, the water used in many of these lithium and copper mines are located in very high water stress areas in our analysis. So that means that the availability of water can be a limiting factor in the expanding the supply in the future, and also so reducing the techniques, developing techniques to reduce water use in developing production process is quite crucial. And also the waste is another major issue because of the lower ore grade means we may produce a lot of waste to produce the same amount of metals. So that means that waste need to manage it somehow. So how to manage these tailings and waste in a sustainable manner, and also some technology mention to extract minerals and metals from the existing tailings. It's the most crucial technologies to watch out in the future, in my view.
Mm-hmm. Thank you. So there might not only be environmental impact, but also other impact. Our chair, Birte Holst Jørgensen, asked the following question. Have you analyzed the human rights challenges, for example, such as child labor or hazardous working environment, etc., in extraction and processing of critical minerals?
Yep. So I think the other social and the responsible practices is also very crucial element to consider when we discuss this topic, because actually the human right is a lot of the attention grabbing from medias and the papers, but it is not the only thing. So the human rights is very much important, and child labor in DRC is actually important, but also there are some other aspects, corruptions and worker safety, and also the transparent revenue management is also very critical to be considered. So in our report, we also look at these various dimensions, and one of our key messages, the two key messages that we need to expand the horizons to incorporate not just the child labor, human rights, but also the other aspect, worker safety and the corruption and others. And also second, some companies, some industry want to disengage with some regions with some problems, but we don't have a luxury to explore all the potential sources. So I think the engagement is an answer. So some companies also work with the local communities to promote sound and sustainable, responsible development practices, and that is some way to go. So we think the more engagement to improve the ESG performance is the way to go, in my view.
Thank you. So I understand, and I guess it's very hard to quantify these impacts there. So we have another question by my colleague Christoph Jessen, which is more quantitative, namely, is the potential of co-dome production, which is difficult to estimate, taken into account in the IEA long-term scenario development?
I'm not sure whether I understood this question correctly. So potential of
co-dome production.
Dome production means maybe co-production means maybe it means byproduct production from, for example, cobalt is produced as a byproduct from copper and nickel development, and so whether that is considered in our the projections or not. If this is the question about that, and I think the answer is yes. So we considered in how this the byproduct production from smaller minerals from the other bigger minerals in the long-term scenario development.
Mm-hmm. Yeah, I'm not sure whether I can reframe this question, because I do not completely understand the focus myself. But I have one question myself, which is since we are essentially the experts group on R&D priority setting, for us it's always important to understand what kind of research directions are the most important, seen from your point. Especially you mentioned the point of recycling also. So which policy measures and also research directions do you consider most pressing at the moment concerning recycling of critical minerals?
Yeah, I think the as I mentioned, technology innovation can play a major role in the helping addressing these challenges. And there are some three major scope of technology innovation. The one is on the demand side. So the reducing material intensity and switching to more amply supplied materials is one way to go. So for example, in solar panels, and we have seen the use of the silver and silicon has reduced quite noticeably in the past decade. And that is the contribution from technology innovation. So that kind of effort, and also very much critical to reduce the burden from material demand, the rising material demand. And on the supply side, and this is often ignored, but also I think it is important to promote technology innovation on the supply side. One is to reduce the emissions of water use in production technologies, and also in the waste, there are a lot of minerals and metals also existing in existing waste and tailings. So how to extract the materials from economic manner, commercial manner is also some one area that technology can play a major contributions. And on recycling, and it's a major sector, and we need to find some solutions. And recycling, the one is about how to design the product in a kind of more conducive to recycling. So for example, in designing the batteries and so wind turbines, solar panels, at least for today, and the recycling is not being considered as a major the consideration when designing the project, but that is also need to be considered, and recycling perspective to incorporate in the product design. And also there are some scope to improve the efficiency of the recycling process, because a lot of losses happening in the sorting and also processing processes. So that is another scope, and also some scope for the harmonized regulations between different jurisdictions, because the flows and recycled product move across the world, but often the many countries and many regions have different regulations, so it's quite complicated. So also some effort to harmonize regulations is one thing to consider to scale up recycling in my view.
So there's still many research directions where research is needed in the future concerning these topics. So thank you very much for this, again, for this very comprehensive review and the presentation. So we put the link to the publication in our agenda. So in the direction of the audience, everybody is welcome to have more in-depth look into this interesting publication. Thank you very much again for your presentation. And then I will hand over to my colleague, Atsushi Kurosawa, the chair of session number 2. Atsushi Kurosawa is the Japanese delegate to the EGRD, and also together with me, one of the vice chairs. He is director at the Japanese Institute of Applied Energy. Thank you, Atsushi.